When we have this kind of problem where this is partial differentiation of u with respect to x but 2 times, but this is with respect to t but 1 time. So how do we write this? Like d squared minus d dashed u is equal to 0, where d is what? Del x. So d square means del 2 del x2, and d dashed means what? Del t. Okay, so now we know that the general solution for this is u is equal to summation over I, and here we don't know where I runs from. So we cannot say this runs from 0 to infinity or 0 to some finite number. We cannot conclude that. So we only write ci e to the ai x plus bi t, where ai and bi are two constants satisfying this equation. Like if we put ai in place of d and bi in place of d dashed, then ai squared minus bi is equal to 0, satisfying this. So this relation becomes, in the next line, ci e to the aix, and in place of bi we will write what? ai squared plus ai squared t. Now we will use the boundary condition, this one, ux0 is equal to pi x, sine pi x. Now ux0 here is summation ci. Remember, we don't know where I runs from where to where. So e to the x, e to the ai x plus ai squared t, ai squared 0, since this is the value of ux0, so we put 0 in place of t, and this is equal to sine pi x. Now this means what? Sine pi x means, first write down the right hand side, e to the I pi x minus e to the minus I pi x over 2i. So the left hand side becomes what? We can conclude the left hand side contains two terms, because in the right hand side there are two terms involving e. So this becomes c1 e to the a1x, and the second term becomes 0, so we don't write that. c2 a2x. Now comparing both sides, we can conclude c1 is equal to 1 over 2i and c2 is equal to minus 1 over 2i, and a1 is equal to I pi, where a2 is equal to minus I pi. Therefore, this is not, this is a2 is equal to this. Okay, no problem. Therefore, uxt is equal to c1 e to the power 1 by e to the power I pi x plus I squared pi squared t minus 1 by 2i e to the power minus I pi x minus I squared pi squared, this is plus I squared pi squared t. Putting these all values in this relation, right? So this becomes, we take 1 over 2i in common, so this becomes e to the power I pi x minus e to the power minus I pi x. Now we take another thing in common, which is e to the power minus pi squared t, since I squared is equal to minus 1, and same for minus I squared. Here we write I squared as well. You can take this minus I pi whole square, which is I square again. So e to the power minus pi square t. This equal to sine pi x into e to the power minus pi square t. And also don't forget to check that this solution satisfies the other boundary conditions, like this: u0t is equal to u1t is equal to 0. u0t here is sine 0 is equal to 0, so u0t is 0, and u1t becomes sine pi, which is again 0. So this solution also satisfies the other two conditions. So thank you.